I'm Daniel Roth. I'm the product manager on the ASP.NET team for Blazor. And in this session, we're going to talk about all the improvements to WebAssembly support in .NET 7. .NET loves WebAssembly. Now, WebAssembly has enabled a new era of modern web development by providing a standard binary-based instruction language for the web. WebAssembly made it possible to use virtually any development platform in a browser to build web applications. Over 5 years ago, the .NET team began on a journey to see if we could run .NET and C# code in any browser on WebAssembly to enable web development full stack with .NET. Now, building a .NET runtime for WebAssembly is a difficult challenge. There are many technical challenges. The runtime needs to provide API compatibility with the .NET Platform APIs within the constrained browser environment. You also need to provide access to those browser-specific APIs and existing JavaScript libraries. At the same time, the download size of the app needs to stay small so that the app loads fast. You need to have good runtime execution performance, as well as tooling for debugging and profiling and logging and tracing and all these things. Fortunately, the .NET runtime team, together with the .NET community, was up to the challenge, and .NET support for WebAssembly is now a supported part of the .NET platform and has been for several years now. This enabled support for Blazor, our client-side web UI framework based on components that is part of ASP.NET Core. By supporting .NET execution on WebAssembly and web browsers, .NET is able to provide a complete full-stack web development experience. You can build your front end and your back end using the same languages, frameworks, and tools, which reduces costs and reduces complexity. Now, in .NET 7, we've made a bunch of improvements for running .NET on WebAssembly. We now have enhanced WebAssembly debugging support, improvements to hot reload. We have expanded the web crypto support on WebAssembly. We're also using the latest WebAssembly features like WebAssembly fixed with SIMD and WebAssembly exception handling to improve performance. We have a new improved JavaScript interop model that's specific to WebAssembly and optimized for WebAssembly. And we even have a preview of multithreading support for WebAssembly that you can try out. Let's take a look at each of these areas. Now, debugging .NET code on WebAssembly is a tricky challenge. We don't actually use the normal .NET debugger to do this. Instead, we connect to your app, to the browser, using the JavaScript debugging protocol, and then we tunnel .NET debugging capabilities through that channel. This has the benefit of enabling you to both debug .NET code and JavaScript code at the same time, but it does make it difficult to provide a full fidelity .NET debugging experience. In .NET 7, we've made a lot of improvements to the .NET WebAssembly debugging support to improve the fidelity of that experience. We now have support for the Just My Code setting. You can inspect multi-dimensional arrays using the debugger. The call stack window will now correctly show the name of your async methods. We correctly handle the new keyword on derived members. We added support for many of the debugging attributes that are in the system.diagnostics namespace, and we just made a bunch of general reliability improvements. Let's go take a look. Let's look at the debugging improvements for WebAssembly in .NET 7. OK, so here I have a default Blazor WebAssembly app that I've got running in Visual Studio. I've already started it up, and I've got it running in the debugger. I've got the counter up, and I've set a breakpoint in the counter component in the increment count method. When I click the button, we hit our breakpoint, and there we are debugging .NET code running on WebAssembly in a browser from Visual Studio. That's pretty cool. Now, down below, we can see the state of everything that's in our component. And it's nice and clean. Now, if I go into the Visual Studio settings and I turn off the Just My Code setting, let's turn off Just My Code. Now we see like all of the internal implementation details of Blazor and ASP.NET Core, and that can be very useful. In .NET 6, this was the only view that you could get. You would get all these additional details. If you ever wanted to just focus, though, on just your code, there wasn't a way to do that, but now there is. You can turn on Just My Code, and the Blazor WebAssembly debugger will now honor that. So that's really nice. Let's go ahead and let this execution continue. Now what I'm going to do is I'm going to add a little bit of code to my counter component. I'm just going to add a random variable here, an array. And this will be integer array, a multi-dimensional integer. I need a new. And then we'll just add some random data in here just to show what we can do with this. All right, so there's that. And I'm going to go ahead and hot reload that into my Blazor WebAssembly app. And that should work. All right, great. We've got the check mark that says that that hot reloaded successfully. Let's go ahead and click the button again so we hit our breakpoint. Now below, notice that we can see our array2d variable, and we're able to now inspect multi-dimensional arrays with the Blazor WebAssembly debugger. That's new in .NET 7 as well. OK, let's continue execution there. The last thing I want to show is in the fetch data component. This is this component that pulls down some JSON data from the server and dynamically generates a table of weather forecast data. It has this onInitialized async component lifecycle method. It's an async method. If we set a breakpoint right here, and then we try to browse to the fetch data page, we hit our breakpoint. And then if we look at the call stack window, notice that we see the actual name of our async method. I think in .NET 6, this would print out like, move next for like every async method, which was pretty bad. Now you get a much higher fidelity .NET debugging experience for your WebAssembly apps. So that's just some of the improvements. .NET WebAssembly debugging just continues to get better, and we're working on continuing to improve it in future releases. All right, let's go back. And let's talk about hot reload. All right, so in .NET 6, we introduced support for hot reload, which is the ability to apply code changes to your running app during development and have those changes apply immediately without having to rebuild the app and restart it. We have hot reload support for WebAssembly-based .NET applications, including Blazor WebAssembly apps. Admittedly, though, the hot reload support for Blazor WebAssembly was initially a bit limited. I think the only thing you could really do was method body replacement. Everything else, you had to actually restart the application. In .NET 7, we've made lots of improvements to hot reload support for .NET on WebAssembly. You can now apply the following types of changes. You can add new types. You can add nested classes. You can add static and instance methods to existing types. You can add static fields and static methods to existing types. You can add static lambdas to your existing methods. And you can add lambdas that capture the this to existing methods that already are capturing the this previously. So all these changes mean that you can stay in your development flow and see changes faster in your running .NET WebAssembly apps. Now, before I move on, it's worth calling out that we know there's still lots of changes that we need to support here to keep that flow really fast and fluid. This is an area of active investment, and you should expect even more improvements to hot reload coming in the upcoming releases. All right, web crypto. On WebAssembly, we've expanded the set of crypto algorithms that are now available when running on WebAssembly. This is the list of new algorithms. Now, I want to make sure it's clear that this doesn't mean that you can now safely store secrets in the browser. Just like with JavaScript-based apps, .NET code running in a browser on WebAssembly can be completely inspected by the user. Any secrets can be extracted from that code. So don't put any sensitive encryption keys or data into your browsers. But you can still use these new algorithms for a variety of purposes, including hashing and so on. What about tooling? The .NET SDK comes with specialized tooling for working with .NET WebAssembly applications. This tooling is available as optional .NET SDK workloads that you can install either from the command line or using Visual Studio. Now, for example, the .NET WebAssembly build tools provide support for WebAssembly ahead of time compilation, which gives you much better runtime performance, runtime relinking, so you can reduce the size of the .NET runtime WebAssembly bundle, and also native dependencies, where you can link in new capabilities into that WebAssembly bundle. You can install these tools for .NET 7-based projects by running .NET workload install WASM tools, or you can select the optional component in Visual Studio. Now, if you still need to work with .NET 6-based projects using the .NET 7 SDK, you'll need to install the new WASM tools .NET 6 workload. The .NET WebAssembly tools, build tools in .NET 7 are not compatible with .NET 6. So if you're a library author and you're using these tools and you still want to support .NET 6 and .NET 7, you're going to need to multi-target it. Okay. There's also the new .NET WebAssembly experimental tooling workload. This is a new workload that contains experimental project templates for running .NET code from JavaScript, as well as preview support for multithreading. These features now are still in active development, so they're not ready for production use yet, and they're likely to change. But we hope that you'll try them out and that you'll share feedback with us. You can install the WebAssembly experimental tools by running .NET workload install wasm experimental. Now, we introduced WebAssembly ahead of time compilation in .NET 6 to improve the runtime performance of .NET apps running on WebAssembly. In .NET 7, ahead of time compilation produces code that is much faster thanks to support for some new WebAssembly features. WebAssembly exception handling and WebAssembly fixed with SIMD, or single instruction multiple data instructions. You can enable these features using the WASM enable exception handling and WASM enable SIMD MSBuild properties. And if you're specifically interested in SIMD, it's worth noting that it's not supported in Safari just yet. The WebAssembly feature is standardized, but Safari hasn't quite got the implementation done yet. Hopefully, Safari will get that addressed soon. We also have a new improved JavaScript interop model for WebAssembly apps in .NET 7. This new model is strongly typed and highly optimized for efficient execution on WebAssembly. In Blazor apps, this new model replaces the existing IJS unmarshaled runtime interface, which is now obsolete. Now, for general purpose JavaScript interop, you're still going to want to use the IJS runtime interface, which will work across all Blazor hosting models. Like if you want to write some JavaScript interop code that works in Blazor Server, Blazor WebAssembly, and Blazor Hybrid, you should continue to use IJS runtime, because those aren't WebAssembly specific. But this new JavaScript interop model for WebAssembly, that is great when you only know you're only going to be running on WebAssembly and you care about getting optimized WebAssembly-based execution. Now, to use this mechanism with existing JavaScript-based apps, you can import the .NET.js JavaScript module into your JavaScript code, it's now a proper ES6 module in .NET 7. You can then use the JS import attribute on your .NET methods to import JavaScript functions so they can be called from .NET. You can then also use the new JS export attribute on .NET methods that you want to make available to be called from JavaScript. Now, this model provides a rich attribute-based programming model for controlling how marshalling is done across the .NET and JavaScript interop boundary. And it also supports sync and async methods. It supports promises and tasks, proxying objects, as well as marshalling callbacks. Now, in Blazor, if you want to use this new JavaScript interop model, what you need to do is you use the JSHost.invokeAsync method to import JavaScript modules into your .NET code. From JavaScript, you can use the new get.NET runtime function to access the .NET runtime that was set up by Blazor so that you can make JavaScript interop calls back into .NET code. Well, let me show you what I mean. All right, let's go back to Visual Studio. OK, so in Visual Studio, in order to show this feature, I'm going to use the new experimental .NET JavaScript, .NET WebAssembly project templates. To show that I've got those installed, we can just run .NET workload list, and there it is. You see I have the WASM experimental workload already installed, and that will give me these new templates. These templates are experimental, but the features that they use are not. They are supported as part of .NET 7. All right, so let's do File, New Project. Here are those two new templates. The first one is a WebAssembly browser app. This is a project that will set up running .NET from JavaScript within a browser on WebAssembly. There's also this WebAssembly console app. This is a project that will run .NET from JavaScript in a console app using Node.js. All right, we're going to use the browser-based one for this demo. And let's call this WASM browser app. Looks good. And we'll use .NET 7. I don't think we need to save that. Okay, now this project is not using Blazor. This is just using the raw .NET runtime capability of running .NET on WebAssembly. In a sense, we're kind of peeking under the hood of what Blazor does in order to be able to run .NET code in a browser. Let's see how we do that. So if we start in index.html, we can see that all that's doing is importing this main.js module, which is defined in the application. In main.js, we're importing .NET.js. That's the runtime API for starting up .NET from JavaScript on WebAssembly. And then from .NET, we're grabbing a couple functions, the set module imports, get assembly exports, and get config. What do we use those for? Well, set module imports allows you to create named modules, sets of JavaScript functions that you want to make available to be called from .NET and C#. Okay, so in this case, we just have one, and we want to be able to get the current browser address location by calling window.location.href. Now in .NET code, the way you do this is you have a class, a partial class, and then you can attribute a static method with JS import. You reference the name of the module that you set up previously. In this case, it's the name of the file. It doesn't have to be that. It can be any string. And then the specific function that you want to bind to. So we're binding this getHref C# method to this JavaScript method in JavaScript land. Okay, let's go back to main.js. So we've set that up. Well, we can call getConfig to get details about the .NET application, like the main assembly name. And then we can use getAssembly exports to get all of the .NET methods that have been exported so they can be called from JavaScript, so the other way around. Here we're using those exports to call myClass.greeting. If we go back to program.cs, we can see that myClass.greeting has the JS export attribute on it, and it's just returning a string. It's actually calling getHref, so it's calling back into JavaScript to get the browser location, concatenating that into a string, and then returning that string back to JavaScript. And it's calling console write line in the process. All right, so that's what this does. And so we get that string back in JavaScript, and then this is just logging it to the console. And it's also putting it into the HTML DOM. And there's no UI framework here. This isn't Blazor. There's no component model. So if you want to interact with the DOM in this world, then you're just using JavaScript interop to deal with the DOM. This is all the stuff that Blazor handles for you. And then we call .NET Run to call program main. In this case, we're using top-level statements. So the only piece of code in our program main function is this console.writeLine. So let's run this. And when this comes up in the browser, it's it's pretty plain. It's not a UI framework here. We're mostly just demonstrating how we can call .NET functionality from a browser. So there. So here's our our string that we got from that greetings method, and it's got the correct browser location. If we go into the browser dev tools and look at the console, we can see all those console logs being written. So and then there's hello browser also from program main. Okay, so that's cool. This is something you can use now to run .NET code from any JavaScript-based code using WebAssembly. Now, how do we use this from a Blazor application? So I'm going to switch out of this project, and I'll show you an example of using this new JavaScript interop model from Blazor. So in this application, what we have, this is going to do hand pose tracking using a JavaScript library. So it uses JavaScript interop in order to do that. The library is MediaPipe, and it does hand pose tracking. So it's going to set up my, hopefully my webcam. But there I am. OK, so if I put up my hands, you can see it knows where my hands are. And then down below, using Blazor, we're displaying some information about which hands are visible and where they're at on the screen. Pretty neat. All right, so how are we doing that from Blazor? Well, if we look at index.razor, we just have this one component, detect hands. We can go to definition on that to see where that's defined. That's in this other Razor class library that we're referencing. And we're setting up the video feed and a canvas to overlay the hand locations. And then we've got some rendering logic that's going to display where the hands are at. And that's all based off of this detection result property, which is defined on the component. Okay, so how is that getting populated? Well, that's all being done using JavaScript interop. Let's go to the code behind for this component. We're in the C# file. So we have uninitialized async for the component. We're checking that we're actually running in a browser, because remember, this JavaScript interop model only works when you're running on WebAssembly. This is not like the other Blazor model where it works with all the hosting models. So this wouldn't work from Blazor server. Here we can call jshost.import async to import a JavaScript module. This is the one that's associated with my component, just sitting beside it in the file system. And we give the set of exported JavaScript functions from that JavaScript module a name that we can then reference later. Okay? And then we call onInit on this Interop class, and that's where we're setting up all of the methods for that handle JavaScript interop. OnInit, here we have the JS import. That's referencing the module name that we imported using JS host. And this is the JavaScript function that we want to call. We want to call this onInit function. And here we can see some of that attribute-based programming model for controlling how types are marshaled across the boundary. It's using a new C#11 feature. I don't know if you noticed, generic attributes. That's pretty cool. All right, so let's go look at the JavaScript code. So where is onInit? Here it is. So onInit gets like a reference to the component instance. And then it's calling get.NET runtime to get the actual .NET runtime instance that Blazor had set up. 0 means, the first one. There's only one. It's the only runtime that you ever need. And then it calls get assembly exports to get all the exported .NET methods so that they can be called from JavaScript. And we just have one of those. I think it's this onResults method that we're using with JS export. Okay, and then somewhere in onInit, we're setting up this onResults callback. And then below in onResults, whenever we get results from MediaPipe with the hand post data, way at the bottom, it actually uses that detect hands export to call back the onResults method in C#land. So that's how we're getting the results back from JavaScript. So that's how this is working. It's pretty cool. Thank you, Pavel, by the way, for setting up that demo for me. What I think is really great about this is showing how you can take .NET code and use it from any JavaScript-based application. It could be Angular app or a React app. It doesn't have to include Blazor in the component model. You can reuse your .NET code anywhere that you can run JavaScript. All right, let's go ahead and shut that down. And let's go back here. Now, the last thing I want to show is multi-threading support. Now, browsers are normally single-threaded. You only have one thread. That means if you do anything that blocks the one UI thread, then your app effectively hangs. There's no other thread to continue execution. But you can emulate threads in a browser on WebAssembly using web workers and then share memory using shared array buffers. So we have a preview of doing this for .NET 7 that you can try out. To use it, you're going to need to install that WASM experimental workload and set WASM enable threads in your MS-Build project file. Now, this isn't supported at all in Blazor yet. That's something we're working on for the next version of .NET. So in order to try out this feature, you're going to have to use these experimental .NET WebAssembly project templates. Let's take a look real quick. OK, so if we go back to Visual Studio, let's open up this math project. Let me make sure I'm on the right branch. I am. OK, so this project, let me go ahead and run it. What we do is this app will solve systems of linear equations. And it's using a .NET library from the community to do that called MathNet. It's a great name. It reminds me of Square One TV from back in the day. And so it tries to solve these large matrix of variables, which takes a lot of compute. At the same time, it's also running a little animation in the corner of just displaying the letters of the alphabet. So in this version, where I'm not using threading, like if I look at the code and what this is doing, it's just calling solve. So it's just running a bunch of compute on the main thread. That will block the main thread. So if I click solve, watch the letters. So we're on N, and it just stopped moving. We wait, the computation completes, and then the letters resume. That's because we blocked the main thread with that solve. So that's a bad experience. We can make this better. Let me switch to a threaded version of this application. And I'm just going to rebuild to make sure that let me stop this. Stop the old app, and let's rebuild the solution. OK, and so in this version, we're now, instead of just calling solve, we're actually creating a thread. And we're doing the calculation off of the main thread. And that should allow the animation to continue. So let's see if that's now working. Hopefully I didn't mess up any caching by switching branches like that. OK, so we've got the animations going. Let's click. Now watch the letters as I click solve. I'm still using the old one. Let me do. That's still the single-threaded version. Let's do this. Empty cache, refresh. I might have. OK, let's. OK, so now if I do solve, yeah, see the letters keep going. while we're calculating, and we solved our system of linear equations. So that's using threading. So we were able to unblock the main thread. So that's a preview of multi-threading, not ready for production use yet, but you can certainly give it a try. Now, all of these great new .NET WebAssembly capabilities enable a whole bunch of new powerful experiences on the web using .NET and C#. For example, our friends on in the Uno platform, they have an application framework for building multi-platform apps that run on a variety of platforms, including the web, using a WinUI-based programming model. They use the same .NET runtime that we use for Blazor. By moving to .NET 7, they were able to dramatically improve their performance. 20 to 50% better performance on their critical paths. They're seeing that exception handling is much faster thanks to that new WebAssembly exception handling support. They're using AOT and getting dramatic benefits from AOT. They're even trying out multi-threading to get smooth UI animations and transitions. You should definitely check out Jerome's talk later today, where he's going to walk you through how they're using .NET 7 to make the Uno platform great. You can learn more about Uno at platform.uno. All right, and with that, .NET 7, lots of great improvements for WebAssembly. I hope you enjoyed learning about them. Be sure to give them a try. Share with us your experiences. Right after this session, Steve Sanderson is going to show using these features to build a real-world Blazor WebAssembly app, so stay tuned for that. And with that, I think we'll now see if there are any questions.